So we sold this lift to a company that makes pizza dough. When the order came in, somebody from our shop was saying, pizza dough is just a bakery. Why is that harmful? What is the hazard?
The flour feels pretty harmless. It's pretty innocuous. But when you launch it into the air, suddenly it's fuel.
Oh, wow. I mean, that's such an everyday thing. You don't think that would pose a hazard. It's in your kitchen and everything.
That's exactly the trap. The flour sitting in the bowl is not an issue, but as soon as you start mixing it around and getting it involved in the air and get into the right mixture, pretty much everything is flammable when you give it the right mixture with oxygen and give it an ignition source. It's a hazard.
Yeah, we know like how fine the pizza dough gets when they're especially frozen pizza, right?
Yeah, and the different types of flours, cake flour, pizza dough, bread dough, the different flours have different concentrations and you get it just right. And
So, and then obviously processing food in an industrial scale, they need electric lifts, they need heavy equipment to roll in there.
You've got motors, you've got contactors, you've got sparking components. Static electricity can be an issue.
When you think gasoline, something you can normally relate with the hazardous, they think they can be hazardous, but like flour and sugar,
Right.
yeah, they don't think.
Gasoline is actually a fuel, but wood dust can be a fuel in the right concentration with air. You don't believe that it's a hazard? Well, look up Imperial Sugar from back in 2008. Dusty environment and ignition source, and the plant blew up.
Wow.
A bunch of people had died in the accident.
Yeah. It was in Georgia.
It was bad.
The same Imperial Sugar packets you see on all these like store shelves.
Sure. Yep,
Okay.
That's exactly it.
14 people from sugar, huh?
Yep. The same physics as in flour. And you get the right mixture in the air, and it's an ignition. It's a fuel source.
When a customer calls us about a lift or a space like that, hey, we are operating here, somebody said we need to look at special equipment because of where we are operating. So where do we begin?
It's not the lift. We don't start there. You have to start with the environment. Some lifts aren't acceptable for certain environments. Just like if it's a wet environment, you don't want to put open electronics into a wet environment, like your phone. You don't drop it in the water. You don't want to bring it in the shower with you.
Yeah.
It's the same thing in
Not
dust.
even a hairdryer, no?
Not even a hairdryer.
Okay.
No baths with the toaster. It's not a good time. The physics is the same. You bring the sparking components into the environment. You have to enclose them and prevent them from igniting the fuel.
Welcome to episode 2 of the podcast for engineered aerial lifts. You're engineered to manufacture aerial work platforms for all your specialized needs. You don't have to do all the calculations. You don't have to do all the regulations. Leave that heavy lifting to us. We'll get you the right lift for the right environment. This is episode 2 of our podcast. We're going to describe what makes an environment a hazardous environment. Eric, do you want to begin with what goes in North America for this classification?
Sure. There's a 3-part vocabulary. It's class, division, and group. So the class, is it gas? Is it dust? Is it fibers? It all starts with the room. What is in the room? Then division. How often present is it? Is it all the time? Is it some of the time? Is it only when there's an incident where something's opened and it starts to fill the environment?
So that's class 1 and class 2.
Class 1 is gas. Class 2 is dust.
I see.
Or flyings, as they would call it, fibers. And then you've got Division 1 versus Division 2. Division 1, it's present all the time. Division 2, it's only in a incident where you've got a process failure or something isn't working properly.
Fueling station per
Or
se.
there's a spill.
Yeah, okay.
Of that nature. Then you've got the groups. So what specific type of fuel is it? What type of dust is it? How volatile is it? So
groups grow from A to
A through G, I believe.
Okay.
A, B, and C are really specialized, highly volatile
rocket
gases,
fuel
rocket fuels. Acetylene is the A, I believe.
I see.
That is one of the most volatile. You mix it with a little bit of oxygen and suddenly it's very explosive. Dusts have a little bit different classification for Class 2, dust, flour, sugar, sawdust from sawing. There's a bunch of different dusts, and they are all classified. You can look them up in the NFPA 70. They're in their National Fire Protection Association code.
The grain processing mills, they get ethanol?
Sometimes they use ethanol or they derive ethanol from what they're processing, but when it comes down to it, they also get some dust. Could be part of the process.
The grain,
It's all in the specifics of they know their process. They know what is the byproducts of the processing. The question comes into how do you classify the environment?
I see.
So we follow the class, division, group.
Okay, that's the 3 parts.
That's the 3 parts. The 4th part is temperature. You have to take that into consideration, especially with dust.
As the components get very heated up, if there's the dust can act as a fuel source, it can catch fire by virtue of how hot it gets.
Right. So how hot the piece of equipment is, dust is going to settle on everything. It doesn't stay in the air forever. It's going to settle.
Okay.
So when it accumulates on the enclosures, on the motors, on the tires, on the surfaces, how much temperature does it take to get that to its ignition temperature?
I see.
How hot does it get?
And that's why Factory Mutual, when they give us a certification, that's one of the final tests they do. They run the machine continuously for 8 hours, see the maximum load that you can put on the system, and then it still shouldn't catch fire.
That is correct. Yeah, and we have to ensure that the motors that we're using are the right size, the components are the right heat absorption or have a way to dissipate the heat efficiently so that we don't create that heat source that could combust the dust or the gas for that matter.
So usually aerospace and defense, like probably a little bit of the mining, oil and gas, these are all pretty common. I believe we also sold something to Purdue Pharma, the processed chickens, right?
No, it was Purdue University where they were doing testing on dust.
I see.
So
we
created and sent a piece of equipment for them to perform. How do these lifts behave in this environment? What are the risks involved? How much dust is acceptable in the air in the environment that they're trying to classify? And it's not just food processing dusts. There's carbon fiber could be, if they're cutting it or abrading it, it could get into the air and be a combustible fuel.
I know things happen in Bangladesh. I've heard 1 or 2 stories where they're processing a lot of garments. The flings from the garment, they can also catch fire based on how fine they get, right? Right,
yeah. Even nylon or some of these custom fibers for your shirts.
Yeah.
The cotton can even be a ignitable dust. If it gets into the air, they're flying around real tiny fibers in the nanoscale.
I see.
If it's made out of carbon, it can catch fire.
Yeah.
Just get the right amount of oxygen and give it a heat source.
And then prevent, because once it starts, there's no time to think, there's no time to get out, there's nothing.
It's too late. Once the heat is there and the environment is right, it's too late. You need to think about it ahead of time. That's why the area classification is important. Is this machine going to be acceptable for that environment? And we don't stop the spark.
Yeah.
We contain the spark from escaping the enclosures, from getting into the overall environment. The enclosures are meant to contain that potential.
So we talk about aerial work platforms, but all the other equipment like AC or the other units that are used in an explosion-proof environment have to be also rated, correct?
Absolutely. All the filter systems with the fans and everything.
Yeah. All the forklifts, anything that you use.
Anything inside of that environment.
Spark.
Yes. The controls cabinet for your push buttons. Your digital displays even, they have to be enclosed so that they don't create a heat source or an ignition source, a spark of any kind.
We work with aerospace companies here, Boeing and the like. Recently, we're getting some interest from Bombardier, Embraer. So these regulations that we spoke about are related to North America, correct?
That is correct. There is a European standards and also a worldwide standard that are out there. Europe being in the ATEX environment, which are zones and other divisions. Worldwide is IECEx, and that is just another level. They follow the most stringent of standards.
I see.
So that you can get transferability.
We've been getting some inquiries from South Korea and Australia. They follow IECEx.
That is correct.
Okay.
And there's a challenge involved with that, and we're up to it. Give us a call if you've got such an environment.
Anything worldwide, if you're dealing with a hazardous environment, if you need to get a lift in there, please get in touch with us. We will guide you the right way. We might not always end up selling you equipment, but we will help you avoid any catastrophes that you may encounter by undertaking that risk without being completely knowledgeable about it.
Your authority having jurisdiction, fire marshal or safety expert, usually from a nationally recognized testing lab, they'll come and classify your environment for you. Urge you to do that. When they get the environment classified, then we can build and design and provide a lift that meets those requirements.
So it's very unfortunate. Sometimes we see these in the news, like some kind of explosion happened. We've been doing this for way too long, and then we can see some of the probable causes. We're not saying always equipment is the source of that ignition, but when we see some of it, what kind of equipment they're using, this is almost nothing compared to human life when you can prevent these catastrophes from happening.
Right. Equipment can be replaced. People is a different story.
Talking about ATEX and IECEx, I've been recently talking with gentleman Clive. He used to help companies that are trying to enter North America that already have the ATEX and IECEx. We might bring him on probably one of these shows so he can talk about how regulations translate between zones. I don't know if I'm getting the acronym right. Reciprocal Agreement to Purchase or something, a RAP. He is much more knowledgeable about it. We'll bring him as a guest on the podcast for you to learn.
Definitely going to be a good episode for sure.
Folks call us, they ask us, do you have this certification? We say, we have FM, but we are regulated by ATEX. Is that acceptable? Sometimes we might be looking for answers that we don't know.
Yeah, the first step is always going to be the environment. You need to get in touch with your authority having jurisdiction, and the fire marshal would be a good place to start. They're going to inspect the entire facility. They're going to say, here's what you need to enclose, here's what you need to prevent, and they'll go through their calculations and figuring out all of the volume of the room, the amount of dust that could be there, the amount of gas that could be there. When does it reach an ignition state? When is the lowest?
The normal operating temperature.
Right. The lowest possible value. Where can an ignition source start? When is it at the right mixture?
So authority having jurisdiction is an interesting thing. If one company has multiple sites across different states or different, even countries might be different regulations, but even if they have plants in different states,
yes.
Yeah.
Yeah, you would have different authorities having jurisdiction over that particular plant in that particular city or municipality. Yeah. It might be a statewide, it might be a region. That's the tricky part. But the first place that I would start would always be your local fire marshal. They'll put you in touch with the right people that would help you classify the environment.
Yeah, just because your plant in a different state is okay to operate with this equipment doesn't mean your new plant might be okay with it. You always have to start with the authority having jurisdiction. It's always about the environment first, and then the equipment comes later.
Yeah, you're always concerned with the safety of the people first, then worry about the equipment.
That covers all the hazardous environment. Anything to add there, Eric?
No, if it's in question, give us a call. Yeah. We'll be happy to help you out. We'll get you in touch with the right people.
And then, like we said before, there's going to be an expert who is well-versed with regulations in North America and Europe and also Asia. So when it comes to IECEx, he can do the translation. He can educate the listeners on how to think about it. If you're in a different zone, let's say Europe or Asia, and then you're trying to buy equipment from somebody in North America, how do the regulations translate and everything? In the next episode, we're going to talk a little bit about the clean rooms. In hazardous environments, we've put the spark inside, contained the spark from getting out.
Right.
In the clean rooms, we are preventing the dust from getting in.
We're trying to contain the dust in the machine or prevent the dust from being created by the piece of equipment into the environment, which would be dust prohibitive. That you don't want dust when you're building a satellite. You don't want it getting into the control systems and stuff that you're trying to assemble to send into space. So how do you prevent that particular situation? And we can help you with that.
These are the clean room versions of the same lifts that we are building. So next episode, tune in. We'll be talking about what kind of stuff that goes through for equipment to be clean room certified. We change some of the greases, we change the seals. There is a lot of process that goes through. The metal flings that come out of a motor running continuously, they can also be considered, they are considered to be.
Yeah, any kind of particulate.
Yeah.
The tires rolling on the floor create particulate. The floor being rolled upon creates particulate. The paint can off-gas. There's a whole slew
Yeah, we'll go into all the details of each one, the process that a machine goes through before it goes over our facility that is clean room compatible. That concludes our show. Thank you, viewers, for tuning in. Any questions you have about not just explosion proof and clean room, anything aerial work platforms related, if you want to customize aerial lift, you know who to talk to. Thank you for tuning in, and then we'll catch you in the next one.
Have a great one.
Thank you.
Stay safe.
Stay informed, stay protected.